All right, welcome back. We are COMP308 in the winter 2019 semester at Centennial Emerging Technologies, week 2, part 2 of our broadcast. We started off earlier today with an intro to TypeScript, and now we're going to get into mean stack, right? So what is mean stack? We were talking about it last week a little bit, and we'll talk more about it this week. So in order for us to start doing that, I'm just going to kind of minimize all this stuff and start pulling up our PowerPoint slides that I put up. I'm not going to read every single one. PowerPoint slides are really for you. Some of this work is coming from the books that I referenced earlier. So it's not just my stuff. So I'm going to talk to it, but not necessarily read them. Again, this is the main book that we're using, but the other 3 books are going to be used later on in the course. The other 3 books are going to cover machine learning, MERN, so Mongo Express, React, and Node, and microservices. Microservices is really cool because it takes this big monolithic application that we're building right now and break it up into different parts. I think it's really cool. We're going to use that. But what is mean? And that's what this is about, this section. We're going to be talking about that. One thing to note is that mean, or most web applications, they're built on this idea of a 3-tier architecture. So when we say web application, not website, website's a different thing. Website is like a mom and pop store want to give me a website that's really like a business card, and it has their name and how to reach them. Or if you're going to make a website for, let's say, a restaurant, a very simple website just that has a menu on it and some ordering information, right? But once you get beyond that and you say, okay, well, I want live orders on the website, or I want to sell products, or I want to have information services, or some kind of application that's running on the web. That's a true application that does some calculations in the back end, or a game, right? Then we move away from regular stuff into this 3-tier architecture, a lot of them. A lot of it is broken down into this model, view, and controller. And this separation of concerns, where we take model, view, and controller and break it up, or take the logic and put it into a controller. The presentation layer, we put it inside views. So let's say for designers, they can work on the presentation. Maybe a front-end developer works on the logic and works with the designer for the views. And then some kind of developer that works on the database is also working on some parts of the controller and the data model, right? So that's what they work on. So it's kind of a taking our monolithic application and breaking down into pieces kind of thing. But we still have this big monolithic application. And the MVC pattern that we're going to see is just that, a pattern. It's actually derived from one of the 23 design patterns that were made by the Gang of 4 in 1994. And for those people who don't know that, you can look it up. Let's take a look at the Gang of 4. So if I look up design patterns. So if you look at software design pattern, and software design pattern, there's different kinds. There are creational patterns, structural patterns, behavioral patterns, concurrency patterns. And the original one was made by the Gang of 4 back in 94. And see if we have that, if they reference it in this one. They may have not. Let's look at Gang of 4. Gang of 4 is, I would say that they are kind of, experts in their field back in the day. They were these guys right here, Eric, Richard, Ralph, and John, who I do not know personally. I'm using their first names like as if I know them, but I do not. And they made up these awesome 23 classic design patterns for inheritance. They wrote it in C++ and Smalltalk, but it's been a book that's been used as I would say, a blueprint for software engineering since then, right? So MVC, Model, View, and Controller Design Pattern, is not new. It's something that's been derived from these design patterns coming back, right? And think about creational design patterns as something like a factory, right? Where instead of instantiating an object directly, like person is equal to new person, I don't want to do that. I want the factory to, parameterize or to structure my my object for me. So I do something like person, let person equal to create person, right? And the create person class, what it does is it's a factory and it creates people, right? It creates a bunch of them, and I can parameterize and it'll structure it correctly in the right way. In a game, it's perfect. If I have a factory for building monsters or enemies, I can have a factory to do that. I can build a bunch of enemies with the factory design pattern. Structural patterns allow us to do things like, design things so that they're more component, component or decoupled sometimes. They also allow us to not use necessarily inheritance, which is actually quite bad, but allows us to decouple inheritance and do things like composition. And there's some great examples of these patterns, which we're going to get into in a sec. And then behavioral patterns are things like the observer pattern. So let's think about the observer pattern as events, an event management system, the observer pattern, where I have an observer and I'm observing something, the observed thing, whatever that thing is. And then I have a client that receives information that I've observed that thing. Oh yeah, look, I'm watching for changes and changes have happened. Hey client, you're my subscriber. Sometimes it's also, the subscriber and a subscription service. That's also a notification. Or think about this as an award system. I have something that I'm doing and then I get awarded because I've achieved an achievement system where I've achieved something. Observer pattern, okay? And so these design patterns are common patterns that we use. Let's take a look at some creational patterns. So the factory pattern is one, like I mentioned. The singleton pattern I use a lot. And the singleton, what it does is it creates an object that only gets instantiated once. And a good example of that is, let's say I go back to the router. Let's say I have a router for my server. I only want to have one. And if I instantiate by accident a second one, I could get myself in trouble. But if I do it and I use a singleton, even if I try and instantiate a second one, there's only ever going to be one, right? So the singleton design pattern is great. Think about them as global variables, right? But in a good way, right? Not a bad way. And there's other ones structurally. You can see things like the flyweight design pattern, which is where I want to have objects that have very similar components to other objects. And a good example of that is where I have, let's say in a game, I want to make a bunch of trees, and all the trees, there's thousands of trees in the game, and each one of them, imagine if I made them all separately and I parameterized them. I had like the trunk, I have the roots, I have the color, texture, the size, the model, all these things, but each one of them were different. Whereas if I use the flyweight design pattern, the model is the same tree. Maybe I tint the tree differently, and I use the same texture for the bark, the stuff, or maybe the trees. You can actually share information between the flyweights, right? As opposed to have individual flyweights all over the place. So the flyweight design pattern reduces the load from using many similar objects, right? So again, some really cool examples that you can use. Again, we mentioned the observer pattern here. Is also the state pattern. Think about it, a state machine, a scene switcher. Or let's say you have an application that has multiple screens, right? And the state machine allows you to move from one state of the application, the start menu, to another state of the application, some kind of calculation that you're going to do, to another state of the application. And you can move from one screen to the other, state management. Or maybe you want to know that you're adding new information into when I'm entering new information, I'm adding information in for an order. I'm in an order taking state, and I'm moving into I've finished my order state and into order processing state. And you can kind of manage where that application goes down and use the observer pattern to kind of indicate to the subscribers that guess what, this particular order has moved from an order that's in progress to an order that's been completed, right? So all these kinds of design patterns are things that have been thought about already. And what we do is we use them as blueprints. So too, the model view controller pattern. Model view controller pattern is a common software pattern because we want to be able to, again, break down these things and apply different people, different resources to each one of them, a separation of concerns. Like I said earlier, concerning ourselves with one thing at a time, as opposed to this big monolithic piece of code that's structured, whether it's broken down across different classes or not, right? So model view controller pattern. And the model view controller paradigm is something that's very common these days. So it's used in iOS application development. If you actually look at Swift and iOS, they use the MVC pattern. View controllers. Think about view controllers, right? Where I have my my view and I have a controller for the view, right? A view controller. And there's also variations of the MVC pattern, MVVM and so on. There's a bunch of other ones. But they're just the same kind of thing. It's kind of breaking up the your code and the components of your application into different pieces, okay, that you can manage. Not quite microservices, not that, but grouping them into similar bundles, if you will. Model view controller kind of looks like this, where you have the user or player, someone who's going to get an experience for the application or game, let's say, and they make a request. The controller, which is the logic, basically processes what the user wants and either shows them a view or accesses a model, a data model that accesses the database that returns information, where the user kind of goes back and forth between the model and the controller, and finally spits out a view or creates a view that is exactly what the user is looking for, and then returns the information back to the user, right? A lot differently than, hey, I make a request and I get a response. It's not just quick. It's not just a request response. It's a little bit more involved than that. All right, so that's kind of the structure that we're going to be using when it comes to mean stack. We're going to use 3-tier application architecture, right? And we're going to start off with one component of the mean stack, and we're going to talk about what the mean stack is in a second. All right, so we have different solution stacks. Originally, there was something called the AMP stack. AMP stack, Apache, MySQL, and PHP. That's a solution stack. Stack means a stack of software. So for example, we had Apache, which is the server, MySQL, which is the database, and PHP, which is the backend scripting language. All right, Apache, MySQL, and PHP. AMP. We have AMP, WAMP, LAMP, XAMPP, all these different versions of the same thing, right? .NET, it uses Internet Information Services as the server. That's Microsoft, right? We use SQL, a SQL server, as the database. And we use .NET MVC architecture nowadays, MVC core, as the backend scripting language, or web forms, if you did COMP308 earlier on, right? So that's the Microsoft stack. And then there's other stacks that use, for example, Python on the front and back end, and Java and Java EE, a really awesome system, not for me. No, actually, it's really great in the enterprise. Java is an enterprise too. It's ultra secure. I think that's the really cool thing about Java. Rock solid, not a lot of changes, so which means it's stable, right? Compared to web. Web is unstable. As you saw, we went from one version to the other in a week, right? That's not good for stability, right? And then there's the mean stack. Mean stack is still a full stack. It uses Mongo as the database, Express as middleware, Node as the server, right? And Angular as the front end, right? Angular. And there's different variations of that. Mean stack, MERN, instead of Angular, React, right? And other ones. So a full stack developer nowadays, most modern developer, is using Node.js. And Node.js is so pervasive, which we're going to get into later, and so popular because it's JavaScript everywhere, okay? So that is exactly what it says here. The evolution of JavaScript, it started off at Netscape way back in the day, and probably most of you don't remember Netscape Navigator. Maybe some of you do. Before Netscape Navigator, there was nothing. There was it's like I feel like I'm reading the Bible. Before, there was just blackness. There was no internet. And then we created the internet in the early 90s. And we had no images, just links and text. That's all we had. I know, that's how it went. And then from there, once we did that, we started evolving some kind of live script, right? That's what it was called originally. And then Java was really, really popular. And so they changed the name of the language to JavaScript because it was popular. And then JavaScript is really the third pillar, right? The three pillars that I mentioned last week, which is, again, structure, HTML, presentation layer, which is your CSS, and then your behavioral layer, which is your JavaScript. So JavaScript was the thing that powered behavior of websites. But then we changed some stuff in 2008. This is a nice mnemonic. Google in 2008 made the V8 engine, V8 in 2008, right? If you're going to remember it, right? And V8 was a cool name because it reminded me, not the version 8 engine, but it reminds me a lot of the V8 muscle cars that used to exist back in the 70s and the 80s, right? You know, a muscle car with a lot of horsepower that sucks a lot of gas, and the V8 engine is kind of like that. It sucks your brain, right? In terms of like the amount of work that you have to do on the front end and the back end. It's pretty crazy. But it's really, really cool because it allows us to use JavaScript everywhere. So it came up with V8 engine. It was very powerful. Chrome basically evolved at that point. And as we went forward, JavaScript was used. And there was an idea to use JavaScript on the back end, which we're going to talk about, because of its non-blocking nature and the fact that JavaScript is event-driven. And everything is in JavaScript is an object. That's another thing that you have to think about. Similar to Python, actually. And then we also had this other piece. So we had JavaScript on the back end. We already had JavaScript on the front end because we were using things with JavaScript itself for behavior. We needed something to power databases, and MongoDB was the first one that came out in around 2009. It was a database that did not require structured query language. So it wasn't, there's NoSQL. That's what it was called, a NoSQL database. So it doesn't have the same structure as SQL databases right now, or SQL-based databases. It's not relational in any way, and it's unstructured like JavaScript. Instead of, think about this, instead of tables, you have collections, and instead of records, you have documents. So it's very JSON-like, okay, in some ways. The advantage of MongoDB is that, again, you're using JavaScript everywhere, so you understand the structure of it. It's unstructured in terms of schema, so every document in the collection doesn't have to be the same. For example, I could have one document record which asks for my name, my phone number, and my address, and you would expect every record in the same collection table to be the same, but actually they're not. You can have something else the next one, and something else in the third one, and completely unstructured on the fourth one. And that might be okay for small applications where you don't need a relational database and you don't need multiple tables. You have small amounts of data, MongoDB. If you're using a large amounts of data, then you still need to use a schema, and you still have to mimic the whole relational database thing anyway. So sometimes MongoDB is not the right solution. Sometimes we combine Node and Express with a SQL server at the end of the day. We can do that still, right? It's okay to do. It's just a solution stack if you want to have everything JavaScript. And then, of course, we moved on to, after MongoDB, we had to figure out some really cool front-end frameworks. And one of them that was very popular was something called AngularJS. So again, this is just a bit of a history. So Angular, let's look at it. It was originally called AngularJS. Now it's just called Angular, right? And Angular is a framework that uses two-way data binding as well as dependency injection and a very complicated structure to pull off an enterprise-level front end, right? I don't know if there's a better way to say it than that, right? It does give you superpowers in many ways if you can master it. I mean, you'll be a superstar if you can master Angular. Angular is the topic of a whole semester. It's not something that you can master, not even then, maybe a couple of semesters if you actually were to break it down into a couple of semesters, right? If I had a front-end frameworks part 1 and a front-end frameworks part 2, we would have enough time to master most of the stuff that we do with Angular. So kind of an 8-month study, right? We don't have 8 months. We have a week, all right? So we're going to do things with Angular within a couple weeks to kind of master the basic principles of Angular. We're going to be doing full CRUD, so create, read, update, delete with Angular and with Express. Okay, we're going to use Angular as a front end, and we're going to consume services on the back end that Express gives us. We'll talk about that. It's going to be a RESTful service that we're going to create with Express, and we're going to consume that service with Angular. Okay, that's what's going to be what we're going to use it for. So this is one popular one. The other one is React, and I'm not sure At this point, I might think that React itself, React.js, is probably as popular or more popular than Angular, I would say at this point, right? So React.js, it's component-based as opposed to kind of monolithic like Angular is, or megalithic, if you will. It kind of creates HTML, which is different than what Angular does. Angular hooks into and injects data into HTML, whereas React creates the HTML for you, almost like component-based creation of HTML, right? With the data embedded. Totally different way of doing things, right? It has something called the shadow DOM, or that's being used on the outside. So it kind of creates this like virtual DOM. It works with the virtual DOM a lot, the document object model, and then injects everything at the end. So kind of a different way of doing things. Angular is a framework. React is not. It uses components. You can plug React into other things very simply. And so this is where React becomes very popular, right? React is not the developer's tool set, though. It is something more of, if you're not a hardcore developer, then maybe React is for you. It's good. If you're a hardcore developer, then Angular is for you, right? And different projects are, kind of lend themselves well to one or the other. The third one that's really popular, that's come a long way, is Vue.js, right? And Vue.js is another popular framework, front-end framework that's being used these days. So those are the three that we were going to talk about this semester. We're going to be mostly using Angular as opposed to React and Vue. And one of the books that we have is, like I said, the MERN stack, as opposed to the mean stack. So we're going to go into more detail with that. But I would suggest that these three frameworks are something for you to know about. And I've copy and pasted the links inside Slack already from this morning. Okay, so those are the three. So again, what we talked about was that it's JavaScript everywhere. So what was really popular was using this idea of a single page application. I have one big page, and instead of me adding a bunch of pages at once, the great thing about front-end frameworks is that they replace the content in the page using something like AJAX, or asynchronous JavaScript and XML, is what it was originally called. Let's not use that anymore. We don't use AJAX as asynchronous JavaScript and XML. We just call it AJAX. Think about it as a reactive component that's part of JavaScript that allows us to update the page without reloading it. Okay, that's what AJAX is really for. We can also use it to inject data into a page, to do things like routing. We can do front-end routing with AJAX, so where we actually don't have the back-end server doesn't do the routing for us. The front-end framework does the routing. So Angular can do routing on its own, right? Which is kind of different. And so the mean stack was born. ECMAScript has gone through a revolution. We talked about some of that earlier today when we were talking about TypeScript. So we talked about how right now we've moved from ECMAScript 5 quite recently into ECMAScript 6 in 2015. And then from 2015 till now, we've had 4 years, pretty much, or 3.5 years of evolution. And we've evolved things. We've added more features to JavaScript. And that's really great, because before that, there wasn't a lot of movement in JavaScript. There was a bit of staleness for a few years when it came to JavaScript's evolution. But nowadays, we demand more and more from browsers. Things like making games in the browser, or even seeing 3D stuff in the browser with something like WebGL. So if we look at WebGL, actually 3JS might be the best way to look at it. 3js.org allows us to do things like make, kind of see things in 3D in the browser, right? And one of the things you can see is you want this three-dimensional stuff to work in a browser, as an example. And in order for us to do this, we have to have the flexibility to continue to improve, the speed of data that's being presented in the browser, right? And in order for us to do this, we have to continue to move forward with JavaScript development. Here, we can actually use VR, WebVR, as well as WebGL to see an object in 3D space. So kind of really cool stuff, all right? So as we continue to evolve, I think what we're going to need is more and more speed. One of the things that's up and coming that we haven't really talked about too much is something called WebAssembly. It's very popular and something that's being pushed forward. WebAssembly will allow us to use things like C++ and C# as a coding language, so your favorite coding language, Java, and then convert it into web, right? You can do it already, and you can do it with something called Inscriptum, right, which allows us to take a C++ program and make it web-enabled, right? And one of the popular game engines out there, Unity, does that right now. So if you actually look at Unity, if you're going to make games, and again, this is for people who are doing it already, Unity is a cross-platform game development engine, and what it allows us to do is make games and other applications across multiple platforms: iOS, Android, Windows, Mac, and the way it does it, it uses, especially on the web, almost like this WebAssembly, converts C++ and the language that it creates into something that's compatible with WebGL, right? Which is kind of really cool. All right, so that is some of the technologies that is starting to power our web, and we continue moving forward with stuff like that as we evolve, right? So that's the stuff that we're doing with ECMAScript 2015. We're adding new features, and TypeScript is at the head of this, because TypeScript is always at least 1 or 2 steps ahead of the ECMAScript evolution, right? On the downside, we can't use TypeScript for everything, and sometimes we'll see this later today. Using TypeScript is sometimes overkill, right? So we have to kind of decide when to use a tool. There's no magic bullet on what's going to make it better or easier for us. We got to use the right tool for the job. Modules have changed in ECMAScript 2016. So far, you've seen module pattern in TypeScript. In ECMAScript 2015 and on, you're going to see that we're going to use the import and export keywords more frequently. So here's an example of lib.js. We have a module, we have a function, half of x, right, as an example, and we export that. We can also import this with ECMAScript 2015, 2016 as something that's called half of from our lib folder, right? And then we can use it inside of another file, main.js, all right? So it's like we require, or we have a dependency on half of, which is an object that we are creating from the lib folder where we export this object. Okay, so it's kind of interesting. Module pattern in ECMAScript 2015, 2016. And you can see that there's more examples of this as we move forward, right? So classes we talked about today really quickly, instance members. We can also do static members both in JavaScript 2015, 2016, the new version of JavaScript, as well as in TypeScript, right? We can use static members, constructors, super constructors. We've done all this already today. I tricked you. You did it with me, and you learned ECMAScript 2016, 2015, all these other things, as well as TypeScript, right? Because it's very similar. And here's some examples in the PowerPoint of how to create classes. Doesn't this look exactly the same as TypeScript? For the most part, the things that are missing are the accessors. We don't have private. We don't have public, not yet. We don't have data types, not yet. They're going to come. Those options are going to be there. You can use a data type or not. You can use implicit typing or explicit typing. It's going to be up to you in the future. And I think eventually we're not going to need TypeScript. Eventually. Maybe it'll be another language. Maybe we'll be using C#. We don't know. Arrow functions is new. Arrow functions is equal sign and greater than sign. And what this allows us to do is return not just the data, but also retain the lexical this. And what that means is that contextually, if I'm going to use an event, then what I want to do when it comes to event-driven programming, I want to keep a reference to this of the class, not of the event scope itself. Sometimes that messes you up, and you can do that with arrow functions. And we're going to see how arrow functions look. Here's an example of a map method or map class, so numbers.map. And what we can do is we can map for every n, we want it to return n squared. That's what this does. So it says, hey, return n times n for every n. That's really what it is. This is a shortcut form for doing that. We can also do things like this. Numbers for each number n, for each n number in numbers, loop. That's a for loop, right? Or for each loop. We can also look at this structure n greater than equal to as something that replaces this function n, right? Almost similar to doing this. So for every number in numbers, do this function, right? Return this stuff, right? Push the number onto evens, whatever the evens collection is, right? So just to show you what that is. So that's something that is you're going to see more and more of. Okay. That's arrow functions. And then we have let and const, which we talked about. I've been using let and const with you since last week. I told you in this class, please do not use var ever, right? We don't use var. var is a no-go, all right? If I see var, you'll lose marks when you hand in your stuff. Just letting you know, right? Because we won't use var. var is bad. var is hoisting. We don't need to use var when we transpile, and we definitely don't need to use var when we're doing things with Node.js, all right? So you might see some older code that uses var. We won't be using it, okay? Let is different than const in that let is like var in that it declares variables. Const declares constants that won't be able to, that don't change, right? Consts are great for classes or references that we're going to be using over and over again that don't mutate, immutable things, right? Let is great for variable names that we want to cast in a particular space, right? And again, you can see that there's no mention of var here, right? Because we're not going to use var. It's just, in your mind, it should be deprecated. var is not something we want to use, all right? All right, and they talks about how to use let and const here, but I've already shown you how to do that today. Default, rest, and spread are a couple of different operators that we could use in ECMAScript 2015, 2016. I'm not going to talk about that here. That's for your own reading. It's just additional collection methods or collection classes that allow you to do different things. But let's talk about mean a little bit. Again, mean stands for Mongo, Express, Angular, and Node, and it has the MVC pattern. It also allows you to serialize and deserialize objects in terms of referencing and connecting with databases and data stores. And then, of course, last week we talked about NPM, the Node Package Manager that allows us to install, update, remove packages from the internet easily and effortlessly, efficiently, compared to doing it by hand. Okay, so that is your intro to mean. Questions around that? Let's talk about Node.js. So Node.js is one part of mean, and this is the last part of our of today. Yeah. Who? Oh, hi. You didn't. Let's do it. That's the best way I think about it, right? So arrow functions. Arrow functions are like a quick way of getting a return type. So here I have, let's say, for example, a function. We have a start method. By the way, if it's formatted terribly like this, let us format the selection, right? And let's suppose I have an event listener like this. Hey guys, I can hear you talking, and it's really annoying. Guys, ladies, hey ladies, I can hear you from over here. It's really loud. It projects everywhere in the room. All right. So here, what we could do is we could use a start method, a named method like this. But that's one way of doing it. What else could we do? We could make it an anonymous function. If I'm never going to call start again, and it's only going to be done once, then let's do something different. Let's make it so that it looks like this. So think about one thing that we use arrow functions for is for shortcuts. So instead of using the keyword function with the callback, we can use it as a shortcut. So like this. So if I want to, normally what I can say is I can do this. I can do function, and then I can take these things here, these curly braces, and I can do an inline function that looks like this, yeah? But what arrow functions allow me to do is actually do something like this, where I can just kind of do the keyword, the function keyword, and do this, right? What if that function, this thing here, returned a value, right? What I can do is I can look at it and say, well, I want to return whatever. And this fat arrow function, a lot of times when I see it, think about it as a similar to a lambda function in C#, right? Where I can return a set of values, right? And I don't have to do the whole body of the function, right? So, arrow functions allow us to do that a lot. And if you read up on how they're going to be used here in Node, a lot of times what they do is we see this format, this way of doing things right here. I can also pass in parameters in here as well if I want to, right? Sometimes I only have one parameter. I can even avoid using the brackets altogether. So it's a reduction in syntax, right? And as well as it retains this. So right now what's happening is in my function, this refers to, in here, it refers to this space, functional space, right? If I pass this in, inside of here, this is the event listener functions this. It's a different this than this. I don't know if that makes any sense. Then that, we'll use that, right? So let's say the keyword this refers to the context of this outer function, right? Typically, right? But when I'm in here, the keyword this in a regular function refers to this scope, right? Well, if I use a fat arrow function, this refers to the enclosing functions this, which sometimes is what we want, right? We want to retain this. We don't want to lose this. Otherwise, we do funky things like say, that is equal to this, right? Makes no sense, right? So we avoid those kind of things by using fat arrow functions, okay? That's what they're for. And we're going to see more of that. Hang tight. You're going to see more examples and other reasons why we use them going forward. But that's some of the stuff, some of the reasons why we use them. A lot of times it's shorthand for returning different data from a function. And like we saw earlier with that n is equal to, or fat arrow n times n, instead of going through passing in an n and then having return n times n, we can avoid all that syntax, all that extra work, right? Okay, so that's this. Let me just undo this so we can go back to what it was. But we are going to replace this in a second. Okay, there we go. With something else. All right, so any other questions before we move into Node? Okay, so Node. So we're going to talk about mean again, and n. We're going to talk about the n part of mean, and you're like, why not the m? Because I mean, logically, we go like Mongo, Express, Angular, and Node. But actually, Node is the basis for everything, right? Without Node, you have nothing. You don't have a server, and without a server, then we can't do Express, which is the middleware between the server and front end. We don't have any connection to a database, Mongo, and we can't even do a front end like Angular, right? So Node is the first thing we need to do. And that's why we're talking about it today. So we also have already talked about closures, so I'm not going to talk about that anymore. It's here for your viewing pleasure and for completeness, right? And again, this stuff comes right out of the book that we're using. So what is Node? Well, again, back in 2009, this is important. Ryan Dahl, I think this is important for us to know when it happened. Remember, the V8 engine came out in 2008, right? V8, 2008. Not that I'm ever going to test you on this, right? Not like that. Like, remember the dates. Like, it's not a history course, right? The War of 1812. You know, back in 2009, in this conference in the EU, this guy, Ryan Dahl, he came up with it and said, listen, there's this really cool idea I got, Node.js. It's a server that uses Node, JavaScript on the back end. And it uses Ajax to create this two-way communication, right? And what it does is it uses a single thread as a single-threaded application, right? And we're going to talk about this in what it was compared to other things. For example, the other stacks, Apache, MySQL, and PHP, when you're running Apache and I have multiple users connecting to an Apache server, what I do is I do multi-threading. And you might think that's faster, actually, because I have like multiple threads, one thread per user. You come in, you do a request, and you get your own thread, okay? And you have separation, and you have security, and blah, blah, blah. Actually, PHP probably the most insecure scripting language in the world, but that's just my perspective. I'm sorry, I'm a little jaded when it comes to that. But anyway, so you have this this idea of, you know, multiple threads or multi-threading, and it was cool. Oh, multi-threading is awesome. But what happens when you only have 10 users accessing the website? You have all these like thousands of threads hanging out, right? So it's more memory consumption. And sometimes what happens is you have to throttle up. Like I have a busy Christmas time. I'm selling lots of products. I'm using a PHP server. I create a bunch of threads. What happens to those threads? They hang out. They don't go away. They stick there. And so you have a higher memory consumption when it comes to adding additional threads, one per each user. And then there's speed, right? PHP, whenever there's thread creation that takes place for this multi-threading and concurrency, there's overhead. And when overhead is happening, you're a little bit slower and a little bit, it lumbers along. PHP is really slow. A good example of that is try and use WordPress, right? WordPress gets like slower and slower as you keep accessing it. It's really bizarre, right? Even if you use caching, you have to do all these little techniques to make sure it works, right? I'm not sure if it's just the WordPress part, no matter how efficient they make WordPress. It's great if you're going to make something small, but if once you start going bigger and bigger, you have a million plugins, and it's all PHP, and the backend is a crazy database, MySQL, which is also, you're using relational tables and everything else, probably overkill for a lot of applications. And so it makes it so it's like, web development is a chore. Plus, you have to learn HTML, CSS, JavaScript, PHP, Apache, and MySQL, right? Different technologies all lumbering together. How the heck are you going to do that? And plus have a life, like actually go out and, enjoy your time with your friends, or your wife or husband. So that's a real problem. So they're talking about this like idea of JavaScript anywhere and how the nature of non-blocking sockets in JavaScript are really, really cool. You don't have to wait for one request to finish before another request starts, right? Whereas PHP, you have to wait for one thing and then the next thing happens. You can use asynchronous language as well, but sometimes it messes you up, right? And also, what about transferring information from PHP to JavaScript? How do you do that, right? That was really weird. Echo, right? I'm going to echo my data into JavaScript. How do I take JavaScript and put it into PHP? That was also a real weird issue, right? There's all this, transferring of data from one thing to the other, and it caused all kinds of bugs and headaches and everything else. Still does today. Nowadays, we have PHP that's more MVC driven. Laravel is a good framework for PHP, and they've solved some of those issues, and they made it a little bit more secure. So they came up with this idea, but then what happened was they chugged along 2009 and had all these cool ideas. And in 2014, Node.js and IO talks between these two factions. I feel like they'd like two gangs. There's two warring gangs, right? They're fighting against each other. They want to make this new product. And one gang says, we want to take over the world. And this other gang says, wait, what are you doing, right? And so they split up and they became two different companies, right? IO.js and Node.js. And they fought. And Node.js kind of went on their own. And the version back then that I was using, and I've been doing this since that time, was like version .1, version .12, right? We're talking about. And then suddenly they came together. They're like, well, let's shake hands. We'll take over the world together, right? And, we're not going to be Crips or Bloods. We're just going to come together and be together as one. And we're going to make this one big, massive Node.js organization. And Node.js went from version 0.1 to version 4 overnight. We're like, what? Wait a minute. I was using it. I was like, what did you say? Yeah, man, did you hear? Node.js, man, they combined forces, and now it's version 4. And I was like, no way. Whoa, there's a lot of breaking changes, I can tell you that. But actually, things went for the better. So they kind of came together, eventually they added things like ES6 support. Earlier versions of Node only supported ECMAScript 5, the older version, right? And the new version started supporting the new software, right? And again, I'm excited about this stuff, and you guys are looking at me going like, "Come, get to it. I want to code. I don't want to do this," right? You guys got to understand this stuff, because I'm telling you, some other people are going to talk to you, and you're going to go, well, I just use Node. I went to my professor's class, and I just use it, and I don't care about the back end, right? Don't think about it that way. It's just let's literally go like this. Say, hey, I get it. I understand that there was a big schism, just like, a church breaking up into two churches, right? Kind of thing. And now they're back, right? And what it does, and I'm sorry to go crazy like this, but it's important to me because I went through that whole thing, and it really messes you up when you go through these revolutions. And still now, they're still threatening again. They're like, we're going to split up again. If you don't follow the right things, if you don't have the right stuff in mind, we might split up again and be separate. Seriously, there's still talks. And that's what happens when it's community-driven, right? So remember, Node.js is open source, and there's the community that drives Node.js. It's not owned by a company like Java. Java is owned by Oracle. Oracle can shut Java down if they want. And they've been doing that with Google, right? They've really been like leveraging on Google or hanging on Google saying, Google, you owe us billions of dollars for your Java being used in Android, right? And that's why Google has been working with JetBrains to develop Kotlin for Android, right? The new language they've been working with. So JavaScript is event-driven, and because of that, it allows us to operate on a single thread. I'm not going to go into too much detail about that. And we have this idea of an event loop. So when you have an event loop in JavaScript, you can see that you can't see my cursor. Let me just bring it closer this way. So yeah, you have this event request, if you will, and it goes into the event queue. So hey, server, I want a website. Okay, it goes into the event queue. Someone else goes up and says, hey, server, I want access to this website. Goes into the event queue. And in my event loop, what ends up happening is we use a single thread and event handlers to return data through callback functions. So routing is literally like that. I make a request. The request gets routed through where it's supposed to take data from and returns that request as a response to the user. So this idea of request response. One thing to note is it does this round trip. So it goes through the server and then comes back at you, right, with a request response. The advantage of using Angular as a front end is it catches those request responses first. So if the request doesn't need a response, it doesn't go to the back end. It gets caught by the front end, right, which is really cool. We're going to talk about that later on. All right, so this talks about an example of how PHP works and how it's got blocking architecture, whereas Node.js is something called non-blocking. Here's something of interest of note. If you kind of calculate how much the memory allocation, if you will, here's what happens when you increase the number of users. So you have a bunch of concurrent connections, and then from a memory allocation, you can see that as we get more requests per second, the amount of memory or the speed, if you will, this is the performance comparison, it starts sliding for Apache, so performance goes down, whereas for Nginx, by the way, you pronounce this Nginx for Node.js, it stays pretty much stable, right? So that's one thing. For single-threaded applications like this, performance doesn't dip even for thousands of extra connections, right? Whereas Apache keeps dipping until it actually stops, right? It doesn't matter how much memory you throw at it. Eventually, it will stop. Here's another really awesome, really great thing for memory consumption. So Apache keeps using more and more memory until it runs out. And then look at Nginx, same memory, because one thread, same thread, doesn't change, right? So really clear architecture example of allocation. And earlier, it wouldn't have been an issue because, you know what? We had our web was quite small. Back in the 1990s when web first came out, there wasn't a lot of users. It was mostly academic institutions, right, and larger companies. Since the 90s, we're talking about now, it's been many years, 28 years. God, I shouldn't say I remember these things, right? But I do remember it, right? And unfortunately, for the last, let's say, almost 30 years, right, the web is blown up, right? It's gone crazy. And it's going to keep getting crazier with everything being IP driven. Everything is a web application nowadays. I got a web on my watch. Pretty soon we're going to have web on our glasses or some kind of IP driven application on our glasses. Virtual reality, augmented reality, self-driving cars, all this other stuff that's going to happen. They're all going to be connected to the internet somehow. Your cars are going to be connected to each other. Each of the cars are going to be connected with city traffic control. Who knows where it's going to go? Right, and everything we're keep adding more and more connected services and products all the time, and they're all accessing data servers, right? Web servers. PHP doesn't seem to be something that's going to last, right? If in this architecture, unless they change their architecture to a single thread, right? Which is, I'm just saying, that's Apache, not PHP. Okay, questions around this. This is architecture we're talking about. We need to talk about this a little bit and never again. Okay, I never want to talk about this again, ever, with you guys. This is like the last boring conversation we're going to have, right? Because for most of you, you just want to get going. You just want to do it. You don't care about how it works. It's just a blind box, right? You don't want to do it, right? Or bird box, which is really popular these days. All right, don't do the bird box challenge. It's bad. It's dangerous. All right. What? You know what that is? Netflix, Bird Box. They go blindfolded because the monsters are going to kill you if you look at them. Right. Huh? Yeah, Bird Box challenge. People do that thing. They kind of walk around downtown Toronto with like, you know, a thing around their eyes, right? I don't know. Don't do it. So JavaScript closures we talked about, you know what they are. Basically, they're a function that encloses another function. And what happens is you have a scope, and it doesn't allow other variables to leave that scope. That's what it's for. By the way, the reason why I'm standing up is to make sure that you guys are entertained. Otherwise, you're going to fall asleep with this architecture stuff, right? Just being honest, because I would. And we talked about closures in a little bit, where you have a function within a function, the child function within a parent function, and you have access to different scopes. We know this as programmers anyway, because we've done extensive kind of practice with scope over the years, right? CommonJS modules are different in Node in that they have this idea of a require statement that we're going to use. We're going to see that. An exports object. So the object is called exports. Why couldn't they have called it something else? I don't know, but they called it exports, which is like export, right? Kind of weird, right? So the exports object is a big object. So when you attach functions and variables to the exports object, it becomes something that's available outside of the file. That's how it works. So when I require that object, anything that I've attached to the exports object, I can access in another file. That's what I'm doing. So this way, it resolves the problem because there is no index.html. We don't have that anymore, right? It's just JavaScript. So there's no way of binding our files like we did earlier today. We can't bind our files in index.html. We have to bind them other ways. We use this. Not the lexical this or that, but this system, all right, is what I'm saying. And we use this module design pattern to do that. Okay. So if you look at it, here's an example. Exports is the object. Say hello is the function. We're actually making a pointer to an anonymous function here, this anonymous function, right? So the exports object, when we do say hello equals, what we're doing is we're creating an object, another object called say hello, just by using it, because that's how JavaScript works, right? And we point it to an anonymous function. This anonymous function, and the result of which is going to be attached to the say hello object that's part of the exports object. Yeah, let's try that again. Exports container object, the object that surrounds the file. Okay, I want you to think about that, right? You can attach whatever you want to it. In this case, the say hello method, right? The say hello method points to, that's what the equal sign is, an anonymous function. So therefore, the say hello method has the same functionality or the prototype of the function available to it. And what this allows us to do is whenever we include hello.js, and we can do that by using a require statement that looks like this. Notice that there is no JS at the end of hello because we don't need to. It's not required. That syntax, you don't have to put JS. Just put, I want to require hello, right? When I require hello like this, just this part, you create a reference to the export object inside of the hello constant. So the export object that's part of the hello.js file, and I guess, by the way, this is all named terribly too. I mean, it would be nice if things were named differently. But let's say this hello constant, this variable, this identifier, whenever I have an equals, I point to, as a reference, I point to that other export container, which is part of the other object, the other file, right? And because export has a say hello method that's attached to it, so too does hello. Because hello is the export container now, right? Phew. Let's try it. Doing it like this, but trying it, that's a whole different thing. You won't be as bored. So let's get to it. So we're going to abandon this lesson for a second, and we're going to make a new one. All right, and the way we're going to do that is we're going to go back to the desktop. Let's do this together. This is part of your submission for later on today, right? I'm going to make a brand new folder. So new folder, and we're going to make it COMP308 and winter 2019 as an example, and it's going to be lesson 2D because we have C, that was the first one. Lesson 2D is empty right now, okay? I want to start off with an empty folder. Okay, cool. So that's great. I have this empty folder. I want to run it with Visual Studio Code. I'm going to bring up Visual Studio Code and drag and drop. There we go. Empty folder, nothing else. We're going to put this up on GitHub in a second too, but one thing at a time. All right, great. No folder, and best place to start is in the Node.js website. Let's go to the Node.js website. And if you notice, the Node.js website has a docs link. Follow me here, guys, because it's going to get pretty hairy in a second. All right, here's docs. Let's click on docs. Under docs, you have a bunch of different ones. You can go with ES6 and beyond, right? A set of documentations for that, right? You also have guides. Let's go to this guides first. So guides. When we look at guides, you have the Getting Started guide. There we are, the Getting Started guide. And it gives you a little bit of code to get started. We're going to use this code as the basis for what we're going to hand in later on, okay? Let's clip this one line at a time. So I'm going to take this code here, copy it, and I'm going to go into my project, which is right here. I'm going to make a new file called server.js. So server.js. Notice there is the lack of index.html, no index.html, right? And I'm going to paste that line. There we go, const HTTP. I'm going to save it, require HTTP. And you're like, wait a minute. Node is component-based, right? Node is written in C, right? That's what it's written in. And it has, in order for us to expand the functionality of Node, it has the bare minimum functionality. It allows you to serve up files. And if you want more functionality, you have to import them or add stuff with NPM. If I go, hey, NPM, I want this other functionality, whatever it is, I can do that. I can say NPM install Express, NPM install Mongoose, NPM install something else, whatever I want. Again, and NPM is used to get stuff and attach it to our Node server to increase the functionality and increase the utility of the thing that we're building. Okay? In this case, though, there's nothing to install because HTTP and some other modules, FS, which is the file system module, and some other ones are built into Node. You don't have to install any modules for them. They're just something that's part of the Node package, but unactivated. They're not activated. So because they're deactivated, the way to quote unquote activate them is to require them. Okay, so this is another way of doing it. We're going to require the HTTP module, which allows us to listen to this, kind of activate the server. So here, HTTP then is a reference to the object that comes back from the HTTP module. All right, think about that as a separate file that's part of the Node.js file system. Okay. Step one. Two, I have these other two files. I want to grab these two. I'm going slow so that way you can see what these things are. And if you're bored, I apologize, but I need to go slow here because if I don't later on next week, as an example, when we speed up a lot, it's going to kill you. And I don't want the train to kill you. I don't want you to jump on the train. Okay. I don't know if there's a better analogy than that. Probably is. All right, so I've got three constants now. I've got a host name. The host name is 127.0.0.1. Remember, this is the loopback address. A short name for this on your computer is localhost. Same thing, right? Host name is 127.0.0.1. And the port is a friendly port that does not block other ports. For example, we can't use port 80. Because port 80 is the default web address for accessing the web. We can't use port 21 or 25 or 43 or a bunch of other ones, right? And so we use port 3000. That's a popular one. We can also use port 8000 or 8080 or something weird. It's usually just some port that's been that's free and addressable. Okay. And usually think about this. This is the address and the port is the window, right, or the door that you want to go through. Port, maybe the short form of porta from Latin meaning door. I don't know. I'm making it up. All right, let's go back to this part. This part here is, the next part that I want to copy paste, and I want to talk about what this is. So here we have create server. Oh man, what the heck is this create server thing? What do you think it is? We talked about design patterns earlier. What is this thing? Anyone care to guess? How about the girls in the back, way over there? Any kind of guess of what create server is? We talked about design patterns. That's a hint. It's a creational design pattern. It's a factory. That's what it is. It's a server factory. It makes any kind of server I want based on the parameters that I give it. And to make it easier, and then for the gentleman that asked me about fat arrow functions, there's the fat arrow function again, right? So we have parameters, and we have a fat arrow function that retains the lexical this from this function, and it's a shortcut. All right, that's what it is. It's used the exact same way. But if I was going to rewrite this thing, let's just cut this out. Let's chomp this out and try it out, right? I'm rewriting it. I have some kind of server that's been created from the create server factory. That's what this thing is. The factory function, I give it parameters, and it makes the server that I want, okay? By the way, the server that I want is pretty boring right now, right? So I'm going to call this function, I don't know, my server parameters, params, let's say. And my server params is going to take all those things. Let's just take away this extra bracket here and this extra bracket over here. So there's my server params right here. And I'm not going to use fat arrow for now, just to make it simple. And I want to take my server params and pass the whole thing into my create server function. Same thing. I've just decoupled it. I've taken them, I've separated them, right? So I have this my server params, and my server param has two things: a request object and a response. And what's the status code 200? What does that mean? Does anyone remember? Okay. It means okay, status code 200. I'm saying, hey, my response is going to come with a status code that's 200. I'm giving back a status code to the server that says everything is okay. And I'm also setting the header of the file to a content type of text plain. That's what I'm doing. I'm saying it's plain text. It's not HTML. It's not JavaScript. It's not CSS. It's just plain text. And I'm going to respond with hello world. It doesn't matter what you ask. I'm always going to say, if you say, what's the gravitational constant of the universe? I'm going to say hello world. What is, how old are you? Hello world. What's your name? Hello world. Right? That's all I'm going to respond every single time. I want the index.html. Hello world. Right? Whatever you ask me for, in this case, this server is so dumb, it's always going to respond with hello world. For now and for forever, as long as I have this server. Right? So that's what this create server stuff does. Create server creates a server based on the parameters that I've given it. Okay? So I'm just going to do that, make it all one. I'm never going to use those parameters again, so it doesn't make sense for me to have a dedicated function for it. I might as well make it inline like this. It's actually more efficient and from a memory perspective, right? Whenever I allocate a named function on the stack, it takes more memory than actually doing an inline like this. And that's why you can see a lot of this going on, like I mentioned last week, as opposed to named functions. This is a lot lower in terms of overhead. Okay, last thing that we have here is this part, this server.listen, all right? Server.listen. And if you look at this, if I kind of punch this in, server.listen is actually using the server object we just created with the create server factory method, right? And we're listening on a particular port and host name, which we defined up here, right? And then again, we're using the fat arrow functions to basically as a callback, an inline callback function that does a console log by using backtick. Look, here's the backticks that we're using right here, and kind of injecting the host name and port when we're listening. By the way, the console, one thing I failed to mention this morning was the console. Where is the console? There's no browser. The console, is your terminal. That's where the console log is going to spit things out. And that's a totally different thing. So whenever you run a server, the target for your console is not, absolutely not, the browser. It is your terminal, right? The terminal window, right? And so know this. This is a feedback for you as a developer, not the user, that everything is okay. Okay? All right. This is good. But I want to be able to run this thing, and I need a console. Let's pull it up. So I'm going to control backtick, right? And I want to run this thing, and the way to run my server.js file is to call it with Node. So here's the Node, okay? And notice it's just frozen. It's waiting to listen to you. It's waiting forever. And if I go back up online, if I go back here and I put in localhost 3000 and press enter, it's going to respond with hello world. Doesn't matter what you put in here. If I put in localhost 3000 / index.html, right? Doesn't matter. Whatever I put in here, hello world. I can put in, you suck.html, or just, how about this? Just you suck.html, hello world, right? I want a lot of money. I want $1 million, hello world, right? Doesn't matter what I say. It's always going to respond with hello world. You get it? I request something. It doesn't matter what I request. It's always going to respond with the same thing. Okay? And that's the kind of server that I created. It's a dumb server. It's an example of how this works, right? We don't want a dumb server like this. We want a server that responds with something else, right? And we're not going to get there today, okay? We're going to get there next week. Next week, we're going to make a little bit smarter servers. Only a little bit, though. Because if we make it too smart, that's it. So here's something that we also have to do. What if I wanted to change this so the server's still running? What if I want to make the response goodbye, cruel world, like we did earlier? Can I do that? If I want like this, if I change this right now, it's still running the server. Do you think it's interactive that way? So goodbye, goodbye, cruel world. And I'm saving it, right? Here, I'm saving it. And if I go back to this and if I refresh, I get hello world. Wait a minute, I changed my server. It should respond. No. You know why it shouldn't respond? Because that server is an instance. It's a server instance, an object that I created with my parameters, right? These parameters, whatever I had there before. And when I instantiate it and it's listening, it's going to be that same instance until I kill it. Unless I kill it, it's going to have the previous instance parameters, which means every time I make a change, I've got to shut my server down like this. I'm sad. I got to shut my server down. I'm going to Control-C it. If you're on a Mac, it's Command-C. And when I Control-C, I shut my server down. And if I go back here and if I refresh, it should get an error now because it's trying to access something that doesn't exist, right? And now if I restart my server by doing node server.js and press enter, guess what? And if I respond now, it's going to say goodbye, cruel world, because now I've made a new instance with new parameters for that server. So every time I change the server parameters, I've got to reset it. This is a key lesson for today, right? Your job today is I want you to create this server for yourself in a second, and I want you to put your username or your student ID in there and your name and say, Ryan, as an example, I got to use your name once a day. Ryan with student ID of whatever is ready, right? Something like that. I want you to put your name in there, something silly, right? But I want you to build this server out, the same server that I gave you an example of, and try and work with the server to make something silly like that and respond. Local host, yeah, man, local host, right? We're not quite done yet, and I'll show you why. So what if, I'm going to close this off. What if, one thing that I really don't like about Node.js is I literally get almost no code hinting. And we've been talking about TypeScript this morning, right, and this afternoon, and I'm not using TypeScript for anything right now. Wouldn't it be nice if I could get code hinting for this stuff? Because it's Node. I mean, it's not like jQuery or, the document model or anything. And most, editors don't understand about Node.js. Visual Studio Code's pretty good, but it can be even better. And the way to make it better is to add typings, if you will. It's called, I can add code hinting support without using TypeScript. How do I do that? Well, we need to do a little bit of work first. So here's what you do. If I want to add code hinting support for any library that we're going to be using from now on, including Angular, Express, jQuery, whatever, right? I can do it like this. I can go npm install. Well, first of all, I got to do npm init. Npm init creates that package.json file, remember? And then I can, it asks me for a bunch of questions here, right? It's like almost like a little batch file that asks me to fill in the information about my application. Let's just enter everything. Enter all the way. Hey, I've created my package.json file instantly by pressing enter a bunch of times. It's so exciting. Okay, I'm going to go and take a look at it. Here's my package.json file, and it doesn't really do anything. But one thing it did do automatically was do this. Start node server.js. What the heck? That's what I typed earlier. This means that it's a shortcut if I want to use npm, I can go npm. Not there. I can go on the terminal. I can say npm start. If I put npm start, it does the exact same thing. Node server.js. There's advantages to this because you can make as many of these scripts as you want to do different things. I want to run a build, a development build. I want to do a distribution build. I want to do this kind of build. I want to do that kind of build. I want to build this. I want to transpile that. I can do a lot of stuff here inside of my scripts folder with package.json. I still got to stop it the same way, just like if it's a bash file. So Control-C to stop, right? But I need my package.json for a bunch of reasons. One, for dependencies. I want to keep track of my dependencies. And there's two types of dependencies. We saw one last week, one type, which was project dependencies. And this week we're going to do development dependencies, which you're going to see right now. All right. So here's a development dependency. I want to make my life easier. Actually, I'll structure it like a user story. As a user, I would like to have development dependencies so that my life is easier when it comes to programming. All right. I know, it's agile, right? We're going to use agile from the very beginning. How do I do that? Development dependencies. So I can go in here and go like this. I can say that npm install. Here's my first development dependency I'm doing with you. At types / node. Okay, now here's the big one. Okay, I can do this, but the coding is very particular about making a development dependency. I'm not done yet. Minus save makes it a project dependency. I don't want that. And if I put a minus dev at the end, minus save minus dev, it makes it a development dependency. All right, not a project dependency. Press enter. It grabs information about Node. So almost like code hinting. It gives me code hinting for Node. More code completion to make my life easier when I'm coding things with Node.js, right? And it installs it in my project. Okay? So what's the effect? Why did I do all this work? Well, if I look at server.js now, and if I hover over create server, I get more information. In fact, I get more information everywhere, right? About how to put things together. And if I ever wanted to do something else, let's say I wanted to do the server by hand, I could do something like server dot, and then I get all this lovely code hinting. Notice these stars? These stars are because Visual Studio Code has installed intelligent or machine learning to help me code, right? So if you see these stars, you may not get these stars. I do because I've installed additional help from my older brain to do machine learning, right? Seriously. There's actually something that you can install to Visual Studio Code and Visual Studio that actually allows you to do intelligent IntelliSense, right? Which is a new thing. You can actually activate it yourself later on. And for those people who care, it is a extension that you can enable. And if you look through some of the extensions, so we have C++, and there's also this C# stuff you can add in if you want it for C#. You can support all kinds of languages here with the stuff we're using. And there's also code snippets for ES6. You can add a bunch of stuff for NPM if you want. Well, you can do NPM inside the the browser, NPM IntelliSense, which does exactly what I just did for you. And a bunch of other things that you can add in here. One thing that I've added into the extension itself is the ability for me to have this intelligent stuff, and I believe it's part of the new build for Visual Studio Code. Okay, going back, so I don't go too much off topic. So yeah, I get some additional help. So if I go dot, I can see that if I click on listen. If I try to do this again, I can open it and it gives me 9 overloads. I can look at different overloads for options for listening, right? It gives me all that information here. As soon as I enter this this new node module that I've installed, right? So it actually works for anything. I can use any current modern JavaScript library. I can go at types and add it in. support for it, which is awesome. That's another thing that NPM does for us, right? And when I add support for it, I get JavaScript support even when I'm not using TypeScript. The same kind of support I get from TypeScript from other libraries because they've added TypeScript to their libraries. For example, all the modern ones, jQuery for sure. Create.js, if you're making games, for sure, has TypeScript support. 3JS, if you're doing three-dimensional stuff, has TypeScript support. And so does Node.js, Express.js, AngularJS, React.js, and I keep going. All of them have TypeScript support. Gives you good code hinting and tooling. All right, so that's what we have to do. We have to add that one in. Hey, if I'm going to put this up on GitHub, again, I need a gitignore file. So please add one. A .gitignore file. And my .gitignore file should have what? Node modules. Don't ever put that up unless you have to. So node modules got to be in there. We're almost done. Now you can almost submit this. All right? I'm telling you. This is how easy it is. And I want you to go into your server where it says goodbye crew world and put something like this. You know, hello from Tom, right? Or your name. Replace Tom with your name, okay? And then, you know, maybe you want to put some other information here. Student ID, blah, 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 blah. Whatever it is, right? Okay. That's part of it. This is all you need for, and you're going to put this up on GitHub. Let's do the GitHub piece. Again, for GitHub, I'm going to go like this. There's another opportunity for you to do another repo. That's why I'm doing this for you on yet another one, right? Git init, git add dot, git commit, -m, initial commit. Okay, so I did all those things, done. So my local repository is ready, okay? I did all that good stuff. You need to do it too, all right? And if you don't remember it, you can get it. Here's where you get it from. So remember when I go up online, you suck. See, it still says you suck. It hates me, all right? If I go up online onto GitHub, so if I go github.com/Centennial College, there it is. If you look there, and you can see that I don't have a repository. I need to make a new one. I'm going to make lesson 2D, just like we made. So I'm going to go in here. This is part of what you need to do for your submission today. Very simple. COMP308-W2019, and then lesson 2D. And if I press enter, I'm going to get some instructions. If you follow most of these instructions, it's going to give you everything you need, except for this part. Replace readme.md with dot. And then you've got these three parts done, the part I just did. And then all you have to do is take these last parts right here, copy them, go back to here and right click, which actually pastes everything automatically. And then if I press enter, guess what? I got a new repo, right? I'm so proud of myself. It's really boring, but it's good for learnings. And this is why I'm showing you how to do it. It's important that you guys know how to do this over and over again because this is going to be required for your tests that we do together. All assignments are going to have repos with them, every single one, okay? And we're going to be using repos through NPM. We're going to be looking at repos online, Git repos. And GitHub, like I mentioned earlier, maybe in the first week, is a key way of getting noticed in the community, right? When you do an interview, they look at your code. Where's your code? On GitHub. It's not necessarily on GitLab, and it's probably not on Bitbucket. Mostly, it's on GitHub, okay? So GitHub is the most popular service. I recommend using it. All right, great. So we've done this. Very, very simple. We've got our code, and we're crazy. We're really crazy, and we want to make this into a TypeScript file, not a JS file. What the heck do we do? And now, this is where you watch, and I do, and you don't do anything. Don't do this. Don't try this at home, people. You'll hurt yourself, right? You can make this all TypeScript, even on the back end. But the problem is the way it's been structured. And we'll talk about this in a second. So how do I do that? Well, first steps first. I change the JS to TS. And then I also got to add a config.json file because I need to transpile, right? Before I do my config.json file, tsconfig.json, I just want to transfer it and see what it looks like. So again, I'm going to rename. Don't do this. All right? If you do it, you're going to hurt yourself. And I want to start adding things. I want to start adding some home code ending. Oh man, look what happened to me. As soon as I did that, all this disappeared. I don't have any code hinting at all. As soon as I went from JS to TS. Why is that? Well, because this is the big culprit right here. Const HTTP require don't exist. If you follow the little light bulb, I can change it from require to import. That's what TypeScript needs. And now it looks like ECMAScript 2015, 2016, 2017. It's the new standard for modules, right? The new module pattern says, I want to import HTTP from the HTTP module, not require it anymore, right? But once I've done that, I have a knowledge of what this is. My host name becomes what it is. I can actually add a value for host name. Host name is of type string. I can do that. I can make my port a number. This links back to what we did earlier today. And if you look at server, server is of type HTTP server. I can do that, http.server. I can specify this. I know my request is an HTTP incoming message, but I can be specific, right? So http.incoming message, that's what that is. And I can also know that my response is a server response, right? So server.response or http.response. So it's a response type, server response. There we go. And what this does for us is it gives me good code hinting for this part, right? Because now my status code makes sense. It's a number. My set header gives me more information, just like before, right? And I'm using TypeScript throughout the whole thing. Now, again, just to mention, it's TS. We need JS, right? Even on the back end, even with all this stuff that we have with port and port numbers, we need to transpile from TS to JS. Good news is we don't have to go to ECMAScript 5. We can stay at ECMAScript 6 on the back end, okay? So when we write our tsconfig.json file, it can look like this. So here's our tsconfig.json file, and we can do our compiler options like we before. Here's my compiler options on the back end, right? And I can do something that looks like this. I want my target, so target, to be equal to ECMAScript 6, ES6, all right? So that's a different thing. And then what I can do is I can still do my module pattern. So module pattern, I want to do CommonJS. I could do that, right? This might cause a problem. Let's see how it works. And I don't care about maps because it's only inside my terminal. So this is the bare minimum now that I have. Yay. Let's see if it actually works, because now we're getting an issue. Now what's happened is things have changed. Take a look at that. That happened automatically. I didn't even do that. As soon as I went to CommonJS, all of a sudden this changed up. I didn't do it. The compiler options did it for me. And now this is why I'm telling you to watch and undo. We got problems. It says that HTTP has no default export. Well, yeah, because HTTP is built in, right? What this is looking for is actually for an HTTP module, like an actual physical file, which we don't have, okay? And it looks like we're getting from server, right? We're getting something from HTTP. And so this doesn't really work for us for module pattern. And this is where we get messed up. So what module do we use, right? If I don't specify module, then we get the ECMAScript 6 module pattern. So if I go back to module is very important, right? So if I go module and if I press Control Space, these are the different types I can choose. I chose CommonJS. I can also choose ECMAScript 6. Let's try that and see what it gives us. So module, target, and module the same. And again, if I go back, you can see that. Let's go back to the import statement that we had before. Import HTTP from HTTP. This is what it looked like before, right? Again, it tells us that HTTP has no default export, right? Because it's looking for an export file from the other thing. And we don't have any other thing. This is part of Node, right? And so this is where we run into problems with our module pattern. Target is good, module is bad, right? What else? How about if we try none? That's an option. The other one is, we can also try system, right? And what system does is it goes back to the original one, right? And notice that that is also not working. Even if we use system, I have to save this first of all. Let me make sure it's saved. And I make sure that, yeah, there we go. It goes green. So this works okay. System. All right. All right, cool. So we've got our TypeScript file. We got this. Everything is fantastic. We need to transpile. Remember, I can do it through command line, or I can press Control-Shift-B. Let's do Control-Shift-B. Control-Shift-B. I choose to do a watch task to transpile, and it transpiles, and I have both the JS file and the TS file. Let's inspect the JS file and see if it's right or if it's wrong. So system.register, and it executes this stuff. What the heck is this? Right? You're going to say to yourself. So system.js, what it does is it actually wraps certain things around the entire object, and it works like Webpack. So yeah, nice, Tom. It was really great here, but it failed me here. All right, so let's go back to the drawing board again. What if I said, going back to this ES6 and saved one more time? Does it automatically change things for me? So save. Do I have an error here? No, thank God. Oh, man. This is why we don't do TypeScript right away, because we don't know how to choose these things. And if I choose none, that's also very bad, right? Because what ends up happening is if I go back to server TS, right, I got this. Even if I save, you still got this problem. Here's a question. Do you think it transpiles even if I have an error? And the answer is it sure does. But it has this weird stuff happening, right? Where we don't want this. Object-defined property, ES module, la, la, la. I don't want this. This is wrong. I want my old server.js back, right? We could always go require. And again, there's other options. If you ever want to know how to transpile or do things right, we always look at the, and this is the last thing I'm covering, guys, all right? But I wanted to talk about this so you understand that, yeah, TypeScript is beautiful. And TypeScript has some amazing documentation. That's why I love TypeScript. TypeScript has a great handbook. It tells you how to do things like classes, things we covered today in class, and objects, and all this kind of stuff. It's fantastic. It also has quick start guides for different things. Hey, look, Node and Express. It has a quick start guide. Let's choose this one, right? And it talks about things like how to do it. I need Node, I need Mongo, I need VS Code. And the thing we're looking for more than anything else, I'm just kind of skipping through all this stuff. I'm really looking for my TypeScript stuff, right? So how do I install, my config.json? And here's my compiler options. So it does use CommonJS, right? My target is ES6. This is important. My module resolution is Node, and that's the thing I need, right? I need an extra little piece of configuration, right? I'm just telling you. So you wouldn't know this unless you looked at it. And that's why I'm not asking you to do it, because it's like you're learning two things at once, right? You're learning Node, which is like, wait, Node, JavaScript on the server. And then at the same time, I'm saying, wait, let's throw in TypeScript on top of that, right? And that's why I'm not asking you to do it right now, okay? But if I want to make it work, let's go back. So CommonJS. So if I want to reconfigure it, go using the code. So this would be CommonJS for a module pattern. And note the module resolution, right, is instead of classic, we can use Node, right? So Node.js. And if I save this, maybe I'll have no problems. I don't know, but it's definitely not this, right? So see how import HTTP from HTTP doesn't work? If I save this now, right, you can see that on the JS side, it still have this ugly stuff going on. And really what we had before was HTTP. Remember we had this thing const, HTTP, and then equals require HTTP. That's what we originally had. We had this, right? Remember this? And then it said, hey, by the way, if we do this, you may want to change this with a little thing. You may want to change this into module pattern, require this, change it to an import. Do I have errors anymore? I don't want to mess you up. And that's why we don't do the things that we want to do, right? This is good now. Now, will it run? That's another question. Does it run, right? So let's try it out. And I'll pull this off by going Control backtick. And I'll make a new area here that I want to do. And I'll just use this thing. I'll say like npm start, because remember, start is node server.js, right? And I'm a champion. That's it, right? All that work for one file, right? I'm not a champion. That's a lot of work for stupidity, for nothing, to give me no added value. So for now, that's why I don't request it from you. Will we get there this semester? Yeah, it's coming. I'm just being honest. I'm just telling you how to do it and how to think about it. What is tsconfig.json? It is a configuration file. We need a couple of additional things in there to make it work. And there's some adjustments we need to make, right? But now if I go back to my local host, and if I host it, so I go local hosts, I get hello from Tom. All right, I feel fantastic, right? It's not exciting. It's still the stupidest server in the world because it always responds hello from Tom, right? But it worked. What do I need from you for today, right? There is another exercise file. I don't need all this. I definitely want you to go up on the server.js, the one we just made, this one. And I want you to back this up a little bit to where we had it before, which is instead of import, you want to make it a const. I'll do it for you. Here, I'll show you how to do it, right? Let's stop all this insanity. Stop the insanity, just like the commercials, right? We'll stop this. And we'll go to here, and we'll go to our task, and we'll stop this too. There we go. We're not doing that anymore. And I don't need the tsconfig.json. Let's get rid of it. And you know, we don't need our server.js the way it's written. We get rid of that. And I'm okay with the package.json. This is okay. That's not going to hurt us to have extra node help, right? So leave that alone. And we'll just convert this, the one line back to what it was, which is const. Like literally, that's all the difference, right? And we'll take these away. We'll say, well, we don't care about this, and we don't care about the port number or the code hinting or any of the extra help it's going to give us, right? We don't care about this part. We don't need it right now. We will need it later. But this is the kind of stuff that we would have to have done if we wanted to use TypeScript. So we don't need any of that stuff. We can save that now, and we can rename this file back to JS. And we've reverted all of our changes. Now we're back to normal again. Yay! Right? Are you with me? I went through that journey with you for a reason, right? Just because you can do a thing doesn't mean you should, right? Remember back to what we said, the Spider-Man quote, with great power, right? I'm not gonna repeat it because I saw the Spider-Verse yesterday, so I was like, wait, I can't repeat that too many times. People think I'm gonna promote the movie, right? It is a good movie, but so what I want you to do for today is just do this. Hello from your name, make a GitHub repo, a brand new one, right? That's the exercise here. Make another repo, try and figure out this file. Look at this file. I went through it in detail, and you might say, well, there's a lot of to do. You've been here and you've listened to my crazy rant, right? You saw me go through the whole process of killing myself and coming back from the dead, right? And now we're back. Okay, that's all I want you to do. Yes.
So you want to give another name other than
not Tom. Make it your name,
no,
right?
No,
yeah.
I'm not talking about that.
Yeah.
I'm talking about the folder name. It currently have less than 2D.
Yes,
so
yes. Another whole brand new lesson that only has this, nothing else. No bootstrap, nothing. Okay. So you can look up this. I've already put this up on GitHub, if I'm not wrong. The exact same thing. It's already there. The only difference is I did this. And if you look at this, you can see that there's no changes because I reverted everything. I literally went back to what it was before, right?
What about the name of the folder? Like, do we have our name?
You would have, here? No, it's up to you. It's an exercise. You can make it exercise 2 if you want. It doesn't matter. I don't care about that. I care about actually seeing remember, you're going to give me the GitHub repo. I won't see that folder. This folder won't exist. It'll be the name that you decide is the GitHub repo name. Okay? Anyone have a question about GitHub repos, and why am I making you do it again? because you need more practice, guys. Traditionally, I'll tell you right now, last year that I did this, the year before that I did this course, the year before that I did this course, people didn't understand how to do a Git repo until like week 6, right before the exam. They had the exam, and they're like, I still don't get it. I still don't get how to do a repo. I don't know how to do git init, git add dot, git commit -7, initial commit. I don't know how to do those things. I don't know how to do a push, right, or a pull. I don't even know what that means, right? I have no clue. Why are we doing this, right? You need to know. So that's why I'm making you do it again. And I'm sorry for the rant, but it needs to be done because we're going to be using Git, GitHub, NPM, Node, JavaScript, TypeScript, Angular, all kinds of stuff coming up. And it's not going to get any easier than this. This is probably the second easiest thing. I think actually this is the easiest one, even easier than last week, right, to do this. Please get this done. If you don't hand it in, it's a travesty, okay? It's an actual travesty. It's very bad if you don't have it. It's like the easiest thing, easiest marks you can possibly get for your participation, okay? So please hand it in. Going forward, one thing that I didn't cover in the PowerPoint, it goes on, right? It talks more about CommonJS modules and so on, and it talks about core modules, which we didn't cover, which I want to cover next week. That's why I didn't cover them this week, because it's too much. I did it in 1 week one time, and I'll tell you that every time I did it, they were like, I don't understand. This is the file system module, and this is really, really cool. We can use the file system to read different files, right? And they have other third-party modules that we can install. For example, Express, which we're going to deal with next week anyway, all right? So wait till next week, and we'll do all this work together, all right? It won't take long. Questions for me for today. Server, what is, if I asked you what's a node server, what would be your answer? Think about that. You should be able to answer it's JavaScript on the back end. It's event-driven. It's non-blocking. It uses a single thread. Those things that I talked about today, right? And it's low overhead. It doesn't take a lot of memory, right? It's more efficient and more performant than PHP, the whole AMP stack. It's more performant. And it promotes the whole single-page application on the front end by using JavaScript on the back end. Oh, wait, all right. Yeah. I know you have to go. Questions? Okay, guys, hand your stuff in, and I'll see you next week. We'll end off a little bit early. Not too much early.